So welcome back, guys. So in this particular session, we'll be talking about the air, right? So already we have talked about many kind of criteria, right? We have talked about the light, sound, radiation. We have talked about the housing, ventilation, and now in this particular session, I will be talking about the air. Basically, I will talk about the environmental meteorology, right? And this is the term meteorology. If you talk about, this is the branch of the atmospheric science, which is dealing with the weather forecasting. And basically, in this particular session, we'll be talking about the air, right? So what we will be talking about in this particular session, so we will be talking about a very vital thing, that is the air, right? Before talking about that, air, basically in this particular session, we shall talk about the pollution, right? So basically, study of pollution and its effect on the climate is this particular term, that is environmental meteorology, right? So basically, it is nothing but the study of pollution and its effect on the climate. Its effect on the climate, right? Let me start with the air pollution, guys. Air pollution, right? Just relax back and listen to the section, right? You might increase the speed as well. But over here, I'm going to tell you that if you talk about the air pollution, right, these kind of terms which I'm going to, tell right now, right, somewhere or other, these are your asked questions, right? And they are having a great potential to coming in your upcoming exams as well, right? So try to listen it at one go, right? And, after that, you shall make your notes, right? And once you will be listening to it carefully, right, the less effort you will be needing in revising the notes as well, right? Okay, guys, with that, let's start with the air pollution. Air pollution, basically, it's a very basic term, right? If you are living in a Delhi NCR or might have visited the Delhi NCR region, right, you will be experiencing what I'm talking about, that is the air pollution, right? So first term which I want to introduce in this air pollution, that is the temperature inversion. So let's talk about what is this fascinating term called as temperature inversion. This was once asked 2 or 3 years back. Temperature inversion, right? So what is this temperature inversion, guys? Actually, what happens is that, it is the rapid cooling of the lower atmospheric layers. In the atmosphere, we are having the layers. So if the rapid cooling is happening of the lower atmospheric layers, this is simply called as the temperature inversion. So what is the temperature inversion? This is the rapid cooling of lower atmospheric levels. Lower atmospheric layers. This is called as the temperature inversion. Very simple. Let's keep it very simple. Due to that, what can happen? The formation of the smoke might be seen in the environment, right? As you can see in this particular picture here, what you can see over here, the smoke, right? So India Gate picture, very beautiful one, but here you can see this is kind of hazy picture, right? This kind of blur picture. Why is it so blur? It's not because of camera quality, it is because of the smoke present over there. Why the smoke is there? Because of the temperature inversion. What is the temperature inversion? This is the rapid cooling of the, usually you are seeing this kind of picture in the winters, you're just going out for the college and you are seeing there's a smoke outside. What is it happening? Basically, it happens due to that temperature inversion. What is the temperature inversion? Rapid cooling of the lower atmospheric layers is actually termed as the temperature inversion, and that can lead to the smoke formation, right? So next time when you're seeing the smoke, please think about the temperature inversion. Okay, guys, next term over here, what are the effects of the indoor air pollution, right? There could be the indoor air pollution and there could be the outdoor air pollution. Due to the indoor air pollution, there are so many of the diseases one human being can be having. The pollution is very dangerous. It is a gradual poison for us, pollution, right? And there are the times when the pollution is actually on the peak, right? There might be some burning of some kind of crops. That might be due to some burning of the crackers. Every Diwali we are saying that don't burn the crackers and all. But usually in a recent report, it shows that basically, the burning of the crackers is not the major cause for causing the pollution, but it is something else rather, right? So over here, let me talk about one more important term over here, that what are the effects of the indoor air pollution? Question might be coming, which of the following is not an effect for the indoor air pollution, or which of the following is coming under the category of indoor air pollution? Okay, effect of indoor air pollution. So let's talk about them as well. So effects of indoor air pollution, right? So what are the effects of indoor air pollution? Here we are talking about the person might be having, obviously think about that, if the pollution will be going inside your body, and how the pollution might be going inside your body through the respiratory tract and all, right? Obviously you are not eating it with something, you are actually, if I'm talking about air will be going inside your lungs only, right, through your respiratory tract and through your mouth, isn't it? So here we shall talk about the lung infections, we shall be talking about the pneumonia, we shall be talking about the tuberculosis, right? We shall be talking about the respiratory infections, right? We shall be talking about the lower respiratory tract infections and etc, right? Along with that, we might talk about the stroke also, right? It is having a bad effect on the health. So there might be the stroke incidences also, there might be the COPD, there might be the heart related disorders, for example ischemic heart diseases, right? So these kind of diseases might be appearing in the person, right? There might be the carcinoma incidences also, for example there could be the lungs carcinoma, there could be the nasopharyngeal carcinoma, because usually these are the areas where the air is actually going inside, or the pollution is actually going inside, right? So these are the areas basically. So these kind of cancers might be appearing over there, right? Nasopharyngeal cancer or the laryngeal cancer might also be there, right? So these are some examples which you should remember for the indoor air pollution, right? Next point over here is what are the indicators of the air pollution, right? So very important term guys, next one, that is the indicators of air pollution. Okay, if you talk about the indicators of air pollution, these are your, so some of the gases are present over there, and among these gases, one gas which I'm going to tell you, this is a very important, very frequently tested in the MCQs as well, that is the sulfur dioxide, right? So here guys, first one which I'm going to name over here, that is sulfur dioxide, SO2 I'm writing for that. SO2 is your nothing but the sulfur dioxide. This is the best indicator for measuring the air pollution. This is the best indicator of air pollution. Very frequently asked question, please do not forget that. Best indicator for air pollution will be the sulfur dioxide, please remember that. Okay, along with that, okay, not only the sulfur dioxide, but with that we might be having the smoke also, right? And for the smoke we are actually talking about the soiling index. For the smoke we are talking about the soiling index, and with that we might be having the grit or dust measurement. For the grit we are measuring the dust over there, right? With that there could be the coefficient of haze, haziness can be there in the environment, so coefficient of haze can be there. Along with that, air pollution index is also the indicator. Air pollution index is also the indicator. Along with that, we are having a suspended particle matter. Suspended particle matter, that is the SPM. Suspended particle matter, that is the SPM. Okay. So believe me or not guys, these indicators have been asked that which of the following is not an indicator of the air pollution. So very important, and among which SO2 is the best indicator for air pollution, right? So please do remember that. Okay, once we know that, this is the thing. In India, if we talk about the pollution over here, it is actually National Air Quality Program is there, which is actually, having the eye on this particular air pollution, and it is controlled under the Central Pollution Control Board, which I have talked about earlier as well in my videos, that CPCB, Central Pollution Control Board, is responsible for taking care of this thing. And here we are having a body which is working, that is the National Air Quality Program. It is actually controlled under the CPCB, right, or sponsored by the CPCB, right? Okay, so Central Pollution Control Board, right? Okay, so once we have talked about that, now we shall move on to the greenhouse effect, guys. We shall move on to the greenhouse effect. Now from your earlier childhood only, you might have heard about this term, that is a greenhouse effect. Let's talk about greenhouse effect. Some of you might be familiar with that from earlier only, right? So here is the sun, you can see, very bright sun, beautiful one, and it is actually emitting out the light. So some of the light might be absorbed by the earth. In the earth we are having the atmosphere, they are having a lot of atmospheric layers also. I told you about the concept of temperature inversion also, which was causing the formation of smoke, right? So here many of the radiation which is coming from the sun, it might be getting absorbed. So most of the radiation getting absorbed by the earth's surface and warms it, right? So you are feeling the warmth of the sun only, right? Then some of the solar radiation might be there which can be reflected by the earth and the atmosphere. Some of the some of the radiation you can see that they are getting absorbed by the sun. Some of the radiation you can see that they are getting deviated from its path. They are getting reflected from the path, right? But what is the greenhouse in this? Greenhouse effect, let me tell you, there are the greenhouse gases actually, guys. I will talk about those greenhouse gases also, right? But over here, the main point is that from the earth, right? Some of the radiation are coming from the sun and getting absorbed into the earth, and some might be getting reflected back. But over here, some of the gases actually, they want to, some of the infrared radiation, look at this particular thing. Some of the infrared radiation, guys, they passes through the atmosphere, but some are getting absorbed and re-emitted in all direction by the greenhouse gas molecules. Because of the presence of the greenhouse gases, the warm infrared radiation, they might not be able to leave the atmosphere of the earth. So due to that, what will happen, because they will not be able to leave the environment, leave the atmosphere, they will be actually roaming in the earth only, right? And that will be causing the unnecessary warmness of the earth, right? So that will be actually increasing the heat of the earth, right? So that is the basic thing over here. So the effect is to warm the earth's surface and the lower atmosphere, right? So basically infrared radiation is emitted by the earth's surface here. Some of the layers will be actually going out, but some of it, they will be actually scattered here and there in all the directions, right? So this is because of the greenhouse gases. Now what are the greenhouse gases we are available with, right? That is also the question. So most important natural greenhouse gases I'm going to talk about right now. So most important natural greenhouse gases, right? Most important natural greenhouse gases, GHG I'm writing, that is for the greenhouse gases. So guys, it could be the water vapor, right? It could be the water vapor. It could be the carbon dioxide, which is the major greenhouse gas. Carbon dioxide is the major greenhouse gas. Okay, I told you for the air pollution it was the sulfur dioxide, and here for the greenhouse gases I'm talking about the carbon dioxide, right? Along with that, CH4 is nothing but your methane, right? Remember, so methane can be the factor over there. Then your tropospheric ozone is also the part of the greenhouse gases, right? And you must know about the nitrous oxide, guys. N2O is the nitrous oxide. So these are the greenhouse gases. Should we remember this? Yes, you should be able to remember this, because the greenhouse gases are asked very commonly that which of the following is the greenhouse gas. Major one is the CO2, guys. Major one is the CO2, and other gases I have already mentioned about. What are the known natural gases, right? What are the known natural greenhouse gases? Answer is very simple. It is nothing but the chlorofluorocarbon, CFC, right? Chlorofluorocarbon, which is actually used in your refrigerator as a gas, right? Okay, guys. Now, there are some international protocols, on the climate change. Climate change, you must have heard about this term, used by many great leaders across the globe. So basically, now let me talk about the international, right? International standard, right? International protocols on climate change. So two very popular one came in the picture. That is one is the Kyoto Protocol, and which was actually the agreement from the Japan, right? And another one was Paris, that is in the France, right? And one more is there, that is the Montreal Protocol. So what are these protocols? Let's talk about them as well, right? So Kyoto Protocol, guys, as I said that it is coming from the Japan, right? It is a city over there. So Kyoto Protocol, it is an international agreement which was adopted in the Kyoto, that was Japan, in the 1997, sorry. So here they were talking about that emission of the carbon dioxide, because carbon dioxide is a very important part of the greenhouse gases. I told you this is a major greenhouse gas, right? And is it natural or non-natural? It is a natural greenhouse gas, right? It was involving the developed industrialized states. So that was the thing over here, not the developing, but the developed only, right? Then aim is to reduce the emission of the CO2 and the greenhouse gases, specific gases, right? And they were talking about first phase was scheduled to be completed by the year 2012, but it was not that successful. Then comes the Paris Agreement. Paris Agreement talks about that, it is an international treaty signed by the Paris, France in 2015 and focuses on the climate change and the global warming. Here they were talking about both the countries, developed as well as developing countries, whereas if you talk about the Kyoto Protocol, they were talking about the developed countries only, right? That was a drawback of the Kyoto Protocol. Then they said aim is to prevent the global temperature rising. right? They were actually trying to they were actually trying to maintain the global temperature by less than 2 degrees Celsius. It means that maintain the global temperature not more than 2 degrees Celsius, right? The heat should not be generated more than 2 degrees Celsius. Second point is they want to limit the temperature, increase to even more than 1.5 degrees Celsius. So that was the term over here, which is the consequence of the emission. So they wanted to, maintain the global temperature, right? Rising up. Then the second term is over here that, time frame they have gave from nation to the most countries and expected that they will be achieving their target by 2025 to 2030. Some of the important features I would like to mention over here is as far as Kyoto Protocol is concerned and the Paris Agreement is concerned. In the Kyoto Protocol, they were talking about the developed countries only, right? And it was signed in the Japan, right? And they want to reduce the emission of the CO2, that was a major greenhouse gas, right? Along with that, it was the linked to the UN framework, right? United Nations framework. So it was linked to the United Nations framework, right? One more point over here, in this one, they were talking about developing countries, and in this Kyoto Protocol only, they set the international target that, internationally, the binding emission reduction, they were the target for the parties, right? Basically, repeat. Okay, so they wanted to decrease the greenhouse gases, mainly the CO2, which was the major greenhouse gas over here, by the 18%, right? By the 18% from 2013 to the 2020. That was their target. So basically, they wanted to reduce the CO2, that was the major greenhouse gas, greenhouse gas, right? Major greenhouse gas by about 18% by the year, right? Or I would write from 2013 to 2020, right? That was the target of the Kyoto Protocol, right? And if you talk about the Paris Agreement, right? In the Paris Agreement, we know that they are talking about the developed as well as developing countries. But over here, they said that, they wanted to strengthen the global response, right? They wanted to take together the developed and the developing countries and about the climate change, right? We have already talked about that. But basically, it was actually dealing with the greenhouse gases emission. Okay, they wanted to complete it, the target which they gave, that is till the 2025, they should be achieving that target, right? Here we have talked about that. So basically, we shall write over here that, they were actually dealing with the greenhouse gas emission mitigation. Okay, the removal of them, mitigation, adaptation by the year 2020. Okay, so they wanted to achieve this particular goal, right? That was about the Kyoto Protocol. Now let's talk about the Montreal Protocol. Now Montreal Protocol, basically they were talking about the depletion of the ozone layer, right? Depletion of the atmospheric ozone layer. So Montreal Protocol, if they will be asking you about the Montreal Protocol, then you shall actually answer Montreal Protocol. Then you shall answer that Montreal Protocol, they were talking about the depletion of the atmospheric ozone. Depletion of atmospheric ozone layer. Okay, fine. Now we shall move on. To the air requirement parameters, right? Now let's move on to the air requirement protocols. Okay, so generally how the question comes, for one person, how much cubic feet per hour is actually required, right? For example, they are saying that for a person, 3000 cubic feet per hour is the requirement as far as air requirement protocols are concerned, and 2 to 3 times the air should be changed per hour, right? That I have talked about in the previous module also. So that is the thing over here. So they said that for one person, if there is a one person, for that one person there should be 3000 cubic feet per hour, right? Okay, now if we talk about the air pollution, we are having the pollutants in our atmosphere. In the pollutants, we are having two categories. One is the primary air pollutant, and another one is the secondary air pollutant. In the primary air pollutants, we are having some gases which we need to know over here. So we are having the primary air pollutants and the secondary air pollutants. Primary and the secondary air pollutants, right? In the primary air pollutants, what do we have? In the primary air pollutants, we are having the carbon dioxide, we are having the carbon monoxide, we are having the sulfur dioxide, we are having the ammonia, with that we are having the chlorofluorocarbon, we are having the ozone also, right? So these are some of the gases which we are having, right? Usually the greenhouse gases also, they are actually involved, right? SO2 I didn't told you in the greenhouse gases, right? In the, if you talk about the CO2 measurement, because that is a major greenhouse gas, guys, it can be measured by the Kiefer method. Once they had asked us that it can be measured by which method, that is the Kiefer method. Now if you talk about the secondary air pollutants, guys, then here we shall talk about the dust particles. Here we shall talk about the dust. Over here we shall talk about, that is the particulate matter. What is this? This is the particulate matter. Okay, this is the dust usually. Okay, usually we are measuring it by the help of, it is actually measured by the grit index. It is measured by the grit index, and that is also your MCQ. One more thing over here, we know that there is a dust. Okay, other than the dust we are having the smoke, and smoke, for the smoke we are having the soiling index, as I told you earlier as well, in the indicator sections, right? So smoke is actually the soiling index over here, and if we will be combining both of them, so both will be considered under the coefficient of haze, right? So both of them are forming, both forms the coefficient of haze, both forms the coefficient of haze, right? Okay, now once you understood that, now we shall move on to the air disinfection, right? So disinfection of air, very commonly they are asking us disinfection of air. If we talk about the disinfection of air, we are talking about the methods, some methods over here. For an example, one method is the mechanical method. Okay, another one, it could be the chemical method. Then we shall be having the radiation method, and we might be having the we might be controlling the dust. Okay, controlling the dust for the disinfection of the air. So if we talk about the mechanical method, what we shall do over here, we shall improve the ventilation. If we will be improving the ventilation, what will happen gradually? Obviously the air will be improving the ventilation. In the ventilation part also, I have talked about this thing, that if the ventilation will be improved, obviously it will be increasing the chances, it will be improving the thermal quality also, and it will be improving the air quality as well. Now chemical, if you talk about, then we shall be using some of the chemical method to disinfect the air. For an example, in the operation theater we are using the fumigation methods, right? We are using the fumigation methods, right? And how we are doing the fumigation? Basically we are taking the help of triethyl glycol or formaldehyde. What is TEG? Triethyl glycol. Triethyl glycol or formaldehyde. By the help of UV rays or X-rays, okay, they might be used for that. Okay, these are the radiation methods. Okay, so very commonly they are asking us about the disinfection of the air. Usually they are asking us about the chemical method of that. Okay, now there are the thermal comfort parameters, right? What are the thermal comfort parameters? Thermal comfort parameters, they are actually talking about various kind of measures of the environment only. For example, temperature, humidity, and the air movement and all. So thermal comfort is very, very important, guys, because every year they are asking you one question from it. Now if you talk about the temperature, it can be measured by, temperature can be measured by air thermometer, can be measured by air thermometer. Okay, if you talk about the humidity, then it can be measured by sling psychrometer or hygrometer. Okay, so please do remember that. Third one is the air movement or the air circulation. It is actually measured by anemometer. Okay, it is measured by anemometer. Don't worry, I will be showing you the pictures as well. Okay, it will make more sense at that point of time. Fourth one, this is the cooling power of air. Cooling power of air means how capable is it to actually cool the air, right? For example, air conditioner or not, right? So it is actually measured by the Kata thermometer. It is actually measured by Kata thermometer. Measured by Kata thermometer. Now, if I will be talking about the Kata thermometer, it is having two types, guys. Kata thermometer is having two types. One is the dry Kata thermometer and another one is the wet Kata thermometer, right? So one is the dry Kata thermometer and another one is the wet Kata thermometer. So here you are seeing that, for example, this is the open temperature, right? Open air thermometer. So this one which we are seeing right now, this is the air thermometer, guys. Air thermometer, right? Usually at some places, there are the thermometer placed over there in the air where, they will be showing you the temperature, that what temperature is it right now according to this particular climate, right? Then we are having this one, you are seeing that this is the sling psychrometer. This is the sling psychrometer, because they might ask you the images as well, guys. That's why we are just discussing this. This is a sling psychrometer. Then you can see here, this is the what? This is the hygrometer. This is the hygrometer, right? Hygrometer, okay, used for the humidity purpose. Now here you are seeing that this is the red color bulb. You are seeing that this is the red color bulb, and this is basically called as the Kata thermometer. This is what? This is the Kata thermometer, right? Here this particular image, you are seeing that this is the anemometer, guys. Anemometer. Here you are seeing that these are the cup shaped structure present over there. So the air will be entering inside them, and it will be trying to rotating it, right? So basically this is the anemometer, right? Then here we are seeing that this is what? This is the radiant thermometer. Okay, here this one is the radiant thermometer, or I would say it is for the radiant heat, guys. So better to call it as globe thermometer. So it is the globe thermometer. It is useful for measuring the radiant heat, guys. Okay, right. So here these are some of the important diagrams with some of the important images which you need to remember. Once again, guys, this is the globe thermometer which you are seeing right now. Then this is the anemometer. Now here it is the Kata thermometer, right? Then there is the hygrometer. This is the hygrometer. Then this is the sling psychrometer, and then there is the air thermometer, right? So once we have talked about that, okay, now you will be seeing the temperature. It will be very easy for you, guys. So temperature we were talking about, then it is actually measured by the air thermometer. Then humidity, if you talk about, it is measured by the sling psychrometer or the hygrometer, right? If you talk about the air movement or circulation, then it is measured by the anemometer. All of the diagrams we have talked about. And cooling power of air is measured by the Kata thermometer, right? Once we have talked about that, right? Once we have talked about that, now we shall move on to one more thing over here. I told you about the Kata thermometer. It is having two parts. One is the dry Kata thermometer and one is the wet Kata thermometer. Okay, the Kata thermometer can also be used to measure the low air velocities, right? So one more important point over here, that Kata thermometer, and this has been asked multiple times. There is an interesting point of this Kata thermometer is that Kata thermometer is used to measure, can be used to measure low air velocities. However, for the air velocities, I told you, for the air movement or the circulation, we are having the anemometer, but still for the low air velocity measurement, we shall be using the Kata thermometer, right? And Kata thermometer can be having two types, dry Kata thermometer and the wet Kata thermometer. It is basically an alcohol thermometer, guys. It is basically an alcohol thermometer. Okay, so this is also very important point as far as Kata thermometer is concerned, right? Images are very important, so please do not forget them, guys. Okay, now as we have talked about that, next one also, right, fifth one also, I would be mentioning over here, that radiant heat, right? It is measured by what? Radiant heat is actually measured by, right, it is measured by globe thermometer. It is measured by globe thermometer. Okay, so again, guys, very important, so please do remember that radiant heat is measured by the globe thermometer, right? And here I have shown you this thing, right? This is the globe thermometer. Here you are seeing that, what you are seeing basically over here, that here this is the thermometer readings present over here, and this is the globe like thing over here. This is the globe thermometer, also used for measuring the radiant heat, right? Now once we have talked about that, we shall talk about the types of temperature, right? We shall talk about the types of temperature. If we talk about the types of temperature, guys, we are having three important types, right? Now very easy to remember, right? Very, very easy guys to remember. One is the simple air temperature. Simple air temperature, right? Nothing very fancy in it. Simple, air temperature is simple air temperature. B is bit complicated. Here we are actually summing up some of the some of the thermal comforts. For an example, this is the effective air temperature. What is the effective air temperature? If somebody is asking us effective air temperature, we are talking about the combination of some of the thermal comfort which we have just talked about, right? For an example, it is the combination of temperature plus humidity plus air movement or circulation, right? With that plus cooling power of air. So if I'm not including the radiant heat, if I will be including these four, if I will be including these four, then it will be called as the effective air temperature. If I will be completing, if I will be including this one also, then it will become the corrected effective air temperature. So guys, effective air temperature and one more term there is, that is the corrected effective air temperature, right? What is the difference between these terms? Air temperature, right? So difference is very, very simple guys, nothing fancy over here. Just remember that if I'm talking about the temperature, with that I'm talking about the humidity, with that I'm talking about the air movement or circulation, right? Along with that, if we are talking about plus, along with that we are talking about the fourth component was cooling power of air, right? So plus cooling power of air, okay, then it is called as our effective air temperature. Okay, very important MCQ. Then if somebody will be asking us what is the corrected air temperature, right? Corrected effective air temperature, then we will be combining everything. We will be combining temperature, with that we will be combining the humidity also, with that we will be combining the air movement or the circulation also, right? With that we will be combining the cooling power of air also, right? That was your right, till here it was your effective air temperature, or you can say effective air temperature plus radiant heat, plus radiant heat. Okay, just for the revision purpose I just wrote everything, otherwise I could have wrote the effective air temperature plus the radiant heat is also called as the corrected effective air temperature. Okay, so very, very important. And what is the best indicator to measure the thermal comfort? So best measure, right, or I would say the best indicator to measure the thermal comfort, which will be the best? Obviously which will be thermal comfort, which will be combining all of the thermal comfort, right? That was your corrected effective air temperature. Very important guys. So this is your best indicator, so I shall write that corrected effective air temperature is the best air temperature, right? So this is your best indicator for measuring the thermal comfort, right? So this is about the types of temperature. Now we shall talk about some of the air comfort index, right? Some of the air comfort indices, right? So now let's move on to the air comfort indices, right? Air comfort indices. Here we shall talk about the zones of comfort, right, on one side, and predictable for sweat rate on the other side. What is this particular thing? First of all, let me explain what is the air comfort index. Basically, it is actually calculated by the McArdle index, right? It is calculated by the McArdle index, right? Calculated by the McArdle index, and here it is also called as the predicted 4-hour sweat rate. This is also called as the predicted 4-hour sweat rate, right? Now you will understand better what I'm talking about. Okay, so predicted 4-hour sweat rate, basically what is the sweat rate, which is the sweat which is coming out from the body, right? So it is actually calculated by the McArdle index, right? That is the same thing over here. So they are usually asking that what is the comfort zone, what is the tolerable zone, or what is the intolerable zone for the human body, right? So they are asking us about the about these kind of things. So guys, on one side I'm just writing zones of comfort, and on the another side I'm writing the predicted 4-hour sweat rate, okay, P4SR. So if I am saying that, in what category I will be saying that there is a comfort zone, in what category I will be saying that just a tolerable zone, and intolerable. There could be 3 categories. right? So comfort zone will be called rather when the predicted 4-hour sweat rate will be in between 1 to 3 liter. If it is between 3 to 4.5 liter, then it will be called as just tolerable, right? And non-tolerable or intolerable if it is more than 4.5 liter or 4.5 plus liter. Okay, that will be called as intolerable zone, right? Now there is a term which is called as the heat stress, guys, right? Now there is a term which is called as the heat stress. Okay, what is heat stress, guys? So the amount of body heat which is coming out from the body to maintain the thermal equilibrium, that is called as the heat stress. Okay, so what is the heat stress, guys? Amount of heat dissipated from the body or coming out from the body, right? Coming out of the body in order to maintain the thermal equilibrium. In order to maintain the thermal equilibrium, that will be called as your heat stress. Okay, now there is one more term that is called as your heat stress index. Okay, so let me just take this over the next page, this particular info. We'll talk about that later on, but right now we are talking about the heat stress. Now one more term which I want to tell you over here is, that is, what is heat stress index, guys? HSI in short. What is the HSI, heat stress index? Okay, so actually heat stress index is actually they are talking about the capacity of the evaporation. We know that to maintain our thermal equilibrium, we need to actually lose the heat in some form, right? So basically by the help of evaporation, by the help of sweating and all, we are actually losing the heat, right? Otherwise what will happen? Otherwise there could be a lot of heat stress, right? Or I would say there could be many other kind of things. For example, heat stroke can be there, right? Or heat cramps might be there. So heat stress index, basically, guys, it is talking about the capacity of the evaporation, right? So they are talking about the capacity of evaporation in this particular index, capacity of evaporation, right? So once we have talked about the heat stress index, right, now we shall move on this is the capacity of evaporation. Now we shall move on to the formula of the heat stress index. Sometimes they're asking us the formula of the heat stress index. So basically that is evaporation which is required for maintaining the heat balance. Evaporation required to maintain heat balance divided by total maximum evaporation that is permissible. Total maximum evaporation that is permissible for the body. This is the heat stress index or HSI, right? What is the range, guys? If they will be asking us the range, that will be 0 to 100. So that will be the range for the HSI, right? So range is very important. Range, what is the range of this one? That is the 0 to 100, right? One more point. Sometimes they are asking us that what is the thermal stress at this particular heat stress index, right? So for that purpose, we shall actually discuss about the thermal stress according to the heat stress index, right? So there could be different values of the heat stress index. For example, it could be 0, it could be from 10 to 30, then 40 to 60, and then 70 to 90, and maybe 100. Okay, so if we are saying that it is 0, if it is 0 heat stress index, that means it is basically nothing, so no thermal stress, right? 10 to 30 is mild to moderate thermal stress, mild to moderate thermal stress. I'm just writing TS for that thermal stress, right? 40 to 60 will be the severe heat strain. 70 to 90 will be the very severe heat strain, and 100 would be the upper limit of the heat tolerance, right? It is just the upper limit of heat tolerance, okay? Or I would say that it would be the heat intolerance, right? This is the upper limit, right? So these are the parameters, right? So once they had asked us that if it is 45, then what will be the thermal stress? It will be the severe heat strain, right? Will it be the mild to moderate, or will it be the mild, moderate, severe, very severe? These could be the options. So in that case, you need to mark the severe heat strain. Okay, so that was asked once, right? Okay, now we shall talk about the humidity. Now let's talk about the humidity. Humidity is basically what amount of water vapor are present in the air, right? So humidity can be of two types over here. One is the absolute humidity and another one could be the relative humidity, right? If we talk about the absolute humidity, basically they are saying that it is the weight of water vapor in a unit volume of air, right? What I'm saying that the weight of water vapor in a unit volume of air, right? Or I shall write a unit which is the unit volume of air. I shall write over here that is a meter cube, right? So unit volume of air. If they are asking us the unit, then you should mention about weight of water vapor. I will consider that in the grams, and volume I will be considering that as meter cube, right? If you talk about the relative one, then we shall say that actual water vapor content divided by total water vapor content. Okay, multiplicative factor will be remaining 100 only, right? Then we are having, okay, the unit of it. Usually we are saying that the humidity is 40% or humidity is 65% or humidity is 53%, right? Like that. So normal range of humidity, we are seeing that it is always expressed in percentage only. The normal range, we are seeing that it is in between 35 to 65%, right? That is always expressed in percentage. Please remember that. Next point over here is that if we talk about less than 35% and more than 65%, what will happen? If I am saying that it is less than 35%, then we are saying that it is very dry environment or climate, and if it is more than 65, then it is very hot and humid climate, right? So generally we are using these kind of terms, right? Now we shall talk about the air pollution monitoring, right? Now we shall talk about the air pollution monitoring, right? Air pollution monitoring is actually, we are generally doing it on the basis of air quality index, right? That is the AQI. You must have you must have seen the AQI basically of different regions in India or in some other place also, and usually for the Delhi NCR region it is very high. It is around 230, 240 or like that, right? So basically on the basis of that we shall be having this particular classification according to the AQI basically, right? According to the AQI basically. So here we are talking about the air quality index, AQI levels, right? Here's the numerical value and here the meaning what they are actually telling. So basically, if the air quality index we talk about, right, it is different for the different regions, right? And usually if you're having some app for the weather, right, they will be actually giving you the notification that in your area this much is the AQI, right? You might check that as well. So if the air quality index or the AQI, it is 0 to 50, right, then usually there is no problem with that. Air quality is satisfactory, right? If you talk about 51 to 100, okay, that is also good only. It is actually moderate air quality. Basically here we are talking about air quality is acceptable, and some pollutants might be there which might be the concern for the health. Otherwise everything is fine. Now the problem starts from the 101 to 150, right? In many regions you can see the 101 to 150 is the air quality index usually found in the India. Okay, and if you will be going towards the industrialized area, for example Delhi and the Delhi NCR area, in that you will be finding even this particular AQI, right? So basically if you talk about 101 to 150, obviously it is unhealthy for the sensitive group. The people who are actually maybe asthmatic, the people may be having some kind of respiratory problem, these kind of people will be suffering more over here. So members of the sensitive group, these will be the sensitive group members who are having the COPD or some lungs problems. Okay, so these people will be more susceptible for this kind of air quality index. They will be having the problems over here, so experience health effects and all. The general public is not generally affected, but the people who are already suffering, they might be actually suffered over here. If you talk about the 151 to 200, it will be considered as the unhealthy air quality index. In this category we are saying that everyone may be having some experience, everyone may be experiencing the adverse health effects over here. Okay, it might be the elderly age group people, or it might be the already suffering people, right? So they will be suffering from this. Very unhealthy, obviously it is a kind of a health warning for the emergency that the people might already be taking or inhaling the toxicated air, right? Next one is the hazardous air. Hazardous air, we are talking about the 301 to 500, right? So it is the lethal air over here. This is the health alert, and everyone may experience the serious health effect issues, right? So here these kind of people might be suffering the lungs diseases, right, in the coming time. Okay, so here these kind of persons might be inhaling so much amount of toxic air. So we have talked about already that it can be the mixture of sulfur dioxide, carbon dioxide, and other kind of gases also. So these kind of persons might be inhaling these toxic gases, right? So basically the air quality index is also coming under which particular board? It is also coming under the Central Pollution Control Board, that is the CPCB, that is Central Pollution Control Board, right? So that was about the air quality index, right? So we have talked about in this particular module, we have talked about the air pollution, we have talked about some of the thermal comforts, we have talked about the indicators of them, we have talked about the greenhouse effect, and at last we have talked about the pollution criteria which checked by the air quality index, right? So I hope you enjoyed the session, and I will be seeing you in the next one. Thank you.